So here we're going to work through three problems, a arctangent, arcsecant, and an arcsine function integral. And so I want to show you how to do this using U substitution. So we have theorem 6.1.3, which is kind of our reference theorem. I don't want you using these theorems here unless I tell you, hey, you can use this theorem, because it's kind of a cheat. So if I want to see work and I'm saying, use U substitution to solve this problem, what I'm about to show you is the technique that I'm looking for. Okay, so here's what I want. When I see 1 over x squared plus some number here, I'm automatically thinking of these three, it looks to me like it matches this form the most, okay? Only thing that's different is the x squareds are switched around, but when you're adding the order, it's commutative, meaning you can a plus b is b plus a. So what I want it to be in the form is 1 over something squared plus 1. Okay, right now it's 1 over something squared plus 16. So the first thing I want to do is turn that 16 into a 1. To do that, I'm going to do some clever factoring, and I'm going to factor a 16 out of both of these terms here. And so if I factor a 16 out of x squared, well, there's no 16, but I can divide through by 16. And then if I factor a 16 out of 16, I just have 1. So now I have this 1 that's desired right here, and I have that 1 that's desired up there. So I'm almost home, okay? So just to make sure we understand we're good, if I multiplied this back through, I get x squared, and then I multiply that, I get 16. So I didn't change anything from here to here. They're the same thing, okay? So now what I'm going to do is I'm going to pull this 1/16 off to the side here, okay? And then the trick is I want it to be something squared. Right now it's x squared over 16. Well, how do I make it equal to something squared? Well, in the numerator, I need it to be x, because that would be x squared. In the denominator, if I make it 4, then that would be x squared over 4 squared, which gets you x squared over 16. So that's my something that's squared. Now, the reason this is helpful is because I know that this something in here is going to be my u, x over 4. So that helps me find my u. Okay, so let's go about solving this. So I'm going to take this. So these two things right here are equal to each other. So that means that the integral here is equal. So I'm going to pull the coefficient 16 out front here. And what I'm going to do is a u substitution. So I'm going to let u equal this inside here, x over 4. Then that tells me that this x over 4 squared becomes u squared, okay? And then what can I do? The derivative of u is du, and the derivative of x over 4 is 1/4 dx. So what I have is a dx here. So how do I get dx by itself? I'm going to multiply both sides by 4, and so dx is equal to 4 du. So I'm going to replace this 1 dx with 4 du, okay? So now I'm ready to pull this 4 out front. Now if I pull the 4 out front, I get 4 over 16, okay, which is 1/4. So this is 1/4 the integral of 1 over u squared plus 1, which this is the definition of arctangent inverse of u. Okay, so now once we get it into this form here, we can just write it out. Okay, so this is 1/4 here, and then this here is the arctangent of u plus c. But since we started in x, I want to finish in x, and so I want to replace u with x over 4. And so my final answer is 1/4 tangent inverse x over 4 plus c. So this is what I mean I want to see whenever you solve using U substitution. Now I will note from the formula that the formula says, 1 over a squared plus x squared dx is 1 over a. And so here, your a is not 4. The a is technically 2 here. No, yeah, it is 4. Okay, sorry about that. So it is 4. So 4 squared gets you the 16. And so then what would you write? You would write 1 over 4 arctangent inverse of x over 4 plus c. But if you just write this alone and you don't show any work with a U substitution, then how can I give you any partial credit, right? So that's more, the formula is there to help check it for you, not for you to just write through the answer. When we get to Cal 2, then we'll be sophisticated enough that we can just say, hey, we know we can run through U substitution and get to here, but why not jump to this answer here? But that's a calculus 2 privilege. All right, let's do another one. So look, same thing here. I started off, if I'm going to use U substitution, I wanted 1 over something squared plus 1, right? So I just turned my a's into 1 is basically what I'm doing. So this one here looks like I've got in the denominator a x and a square root of x squared. That's this flavor right here. So I'm going to want this to be a 1 here. So I'm going to want it in the form 1 over x square root x squared minus 1 form. Okay, that's what my goal is. So I want to get rid of this 25 here. I want to turn it into a 1. That's the goal. So to do this, and note that 25 would be an a equal to 5, and you can get your answer right away from the formula. So you know what the final answer should be. So I want to turn this 25 into a 1. To do that, I'm going to do the same trick that I did up here by factoring out the 16. I'm going to factor out the 25. And so whenever I factor out the 25 from x squared, I have x squared over 25, and I factor out a 25 out of 25, that's just the 1 that I desire, okay? And so now I have 25 times this x squared over 25 minus 1. Well, guess what? The square root of 25 is 5, so I pull the 5 outside to make it 5x, okay? But then inside here, I want it to be something squared, right? So I want 1 over my x, and then the square root of something squared minus 1, okay? That's the goal. So how do I get the something squared whenever I have an x squared over 25 to be something squared? I put an x here and I put a 5 there. So my u in here looks like the inside function is going to be x over 5. All right, thunderstorm rolling in. So I'm going to take the 5, the 1/5 outside the integral using the constant multiple rule. And so now I'm ready to do a U substitution where U is equal to this inside here. And so U is equal to x over 5. And if I'm going to do a U substitution, I need to get rid of all the x's, right? So I need to solve also for x. So x is equal to 5u. So everywhere I see an x, I'm going to put a 5u, okay? And everywhere I see a u over 5, I'm going to put a u. Now the derivative here, du of x over 5 is 1 over 5 dx. So to replace dx, I need to solve for dx. I'm going to multiply both sides by 5, and so I get 5 du equals dx. So everywhere I see a dx, I'm going to replace that with 5 du, okay? So what do I see happening? These 5's cancel each other. So I end up with 1/5 of 1 over u square root u squared minus u, which I know this to be, from my definition, secant inverse of u, okay? So I'm going to go through that math there, and I get this right here plus c. But remember, if u equals x over 5, then absolute value u equals absolute value x over 5. Okay, 5's already positive, so I can drop the absolute value. So this becomes my answer right here. All right? And so once again, with an a equal to 5, then that 1 over a secant inverse of absolute value x over a plus c becomes this right here. So that's the shortcut way, but if I ask you to do the solve through U substitution way, then I want to see this work here. Okay? All right, next up, and this is the last one for this video, I'm going to do the integral from, or definite integral, solve using U substitution 1 over 4 minus x squared. This looks like it's of this form right here, a number minus x squared in the denominator of a square root. So I know my answer is going to be in the form of sine inverse. So I start trying to get 1 over square root of 1 minus something squared. That's the form that I'm looking for. In order to do that, I need to get rid of that 4. So I'm going to factor a 4 out of that. And if I factor a 4 out of 4, I get 1. I factor a 4 out of x squared, I get x squared over 4. So now I want to simplify. I need to rewrite x squared over 4 as something squared like I have here. So that's x over 2. That's my u now. My new u is x over 2. Okay? The square root of 4 here is 2. So I'm going to pull the 2 outside here from that square root of 4 inside. I pull it out. And then this becomes x over 2. So now I have the form here. I'm going to pull the 1/2 out front. Well, maybe not yet. I'm going to do my u substitution first. So I get u here. So I'm going to replace this with this. If that's x over 2 squared, then that's u squared here. That's what's going on here. And then my differential, du, is 1 over 2 dx. Okay? And to solve for dx, to replace dx, I need to multiply both sides by 2. And so everywhere I see a dx, I'm going to put a 2 du. So replace dx with 2 du here. And guess what happens? The 2 here and the 2 here cancel with each other. And so I get 1 over square root 1 minus u squared du. And this, my friends, is the exact definition of arc sine or sine inverse of u plus c. But remember, u was equal to x over 2, so I replace that with that right there. Okay? And so once again, this would be one of those rules where a was equal to 2. And so I have the sine inverse of x over a plus c. And so I literally replace the a with the 2 there for the quick way. All right, so once again, just to double, triple emphasize, don't use the quick way unless I don't specify, okay? But if I say you solve using U substitution or solve showing all work, that's with any test, right? Then I want to see the work to get from here to here, okay, using your U substitutions. All right, so hopefully this video was helpful. I'm going to zoom out so you can see all the 3 different variations.